Find the amount of an annuity that consists of 10 annual payments of 1,000 each into an account that pays 6% interest per year. Observe that there are 10 payments total. The 10 payments are made in the span of 10 years, assuming that the payments are made at the end of each year. So we have 1,000 at the end of the first year, 1,000 at the end of the second year, 1,000 at the end of the third year, and so on. 1,000 at the end of the 10 years. The interest given is known as the APR. This is the annual percentage rate, and it is 6%. The way most financial instrument works is that we do not assume that the money just sits there and not earn any interest rate. We assume that this 1,000, the first payment, will be worth more in 10 years. The second payment will be worth something in 10 years, and so on. Because of this, we assume that these payments are sitting in an account that earns interest. The last payment earns no interest because it is sitting in an account for 0-time interval. This is the payment right before we compute the interest, so that 1,000 stay 1,000. The previous 1,000 had been sitting in the account for 1 year, so the interest it earns and its principal is 1,000 times 1.06. This is because the compound interest for annual interest rate is the amount equals the principal 1 plus r raised to the t, the number of years. R is always in decimal. If r is 6%, then it should be 0.06. The 1,000 deposits 2 years prior to the last payment is now worth 1,000 times 1.06 raised to the 2 power because it has been sitting in account for 2 years. Similarly, the 1,000 prior to that is now worth 1,000 times 1.06 to the 3rd power because it has been sitting in the account for 3 years, and so on. So we have 1,000 times 1.06, and we figured out how many years it had been sitting in an account right before we compute the interest, which is right before the last payment. And so this is 1,000 times 1.06 to the 4th power. This is therefore 1,000 times 1.06 to the 5th power. This is 1,000 times 1.06 to the 6 powers because from 4 to 10 it has been 6 years. This is 1,000 times 1.06 to the 7. This is 1,000 times 1.06 to the 8. And this is 1,000 times 1.06 to the 9th power. And so the amount of an annuity is the total of all of these ending balance. And these are the ending balance again right after the last payment. And that is when we compute the amount. And so we add them all up, starting with the last one. The total amount is 1,000. This is the last payment, plus 1,000 times 1.06 to the 1st power. This is the next to last payment, and so on. 1,000, 1.06 squared, all the way to 1,000, 1.06 to the 9th power. There should be 10 payments in this sum. There should be 10 terms. We recognize that this is a geometric series with A equals 1,000 and R equals 1.06. Although the absolute value of R is greater than 1, but we can still find the sum because this is not an infinite sum. This in sigma notation, n go from 0 to 9 of 1,000 times 1.06 to the n power. Or this is n go from 1 to 10 of 1000 times 1.06 to the n minus 1. The sum of the finite geometric sum or series is a, in this case 1000, times 1 minus r. This r is the ratio, not the interest rate. It is 1 plus the interest rate. In this case, because it is the annual percentage, 0. This is 1 minus 1.06 to the 10 power over 1 minus 1.06. And if we put it in the calculator, we will get $13,180.79. This is money, so we round it to 2 decimal places. We basically compute this amount from scratch. After this, we will learn that to compute the final amount, which we call A sub f of an annuity, we take R, which is the periodic payment, times the quantity 1 plus I raised to the n power minus 1 over I, where I is the periodic rate, not the annual percentage rate, but the period rate. R in this case is 1000 times 1 plus, since the interest is 6% and the period is annual, so we take 6% divided by 1, which is 0.06, and there are 10 payments, minus 1 over 0.06, and if we were to compute this, we will get $13,180.79, which is the same amount that we just computed.